Moin. Hi. Thanks for coming, everyone. We are on a pretty tough schedule. Just to give you a rough idea, I have 130 slides, and we have 30 minutes of talk because I want to give you the time for Q&A. So this almost gives you a movie. I mean, we're in a theater, so I hope this fits. I want to tell you the story of the Looniebox. That's a box we built. You see here on the desk. It's recreating the tape deck experience for my little kids with Elixir nerds and Rfid. So the stuff in technology that I just love tinkering and playing around with. I like to start with a little question, and as I learned during creating this talk, I learned this is pretty controversial. How would you think of a classic adventure, combine these two items? Like, what would you do with that? So in my childhood, I used these two items, and I used the scissors specifically to rewind the cassettes. So when all the tape was thrown out, I used the scissors. I learned that a lot of my coworkers and friends have used a pen for that. And they thought that a scissor may be way too expensive. So I'm living a dangerous life since ever. And that was the problem that I solved with that. Funny enough, I asked my little sister, given we share a mom, so she also had the same idea that she also used the scissors to fix that. And no, it's not to cut the tape, because I still want to use the cassette. Hi, my name is Ole. I work for a company called DNSimple. We do DNS, domain automation, but we don't want to talk about this today. I want to talk about my free time, my spare time project. So there's one little favor I'd like to ask you. There are a few personal pictures in this slide. I think this tells the story way better. If you see any of me or my kids on the slides, please don't photograph them, or if you do, don't share it online. That'd be pretty kind. I will upload the slides afterwards without the pictures, so you still have all the content. So let's rewind a few years, in specific to Christmas 1992. I was 3 at that point, and at this Christmas Eve, I got a lot of presents. And as you can see there in the background, I got this awesome cassette tape recorder. I loved that. That was my first crush. I used it a lot. I sang along. I listened to all these different audiobooks, Benjamin Blümchen, TKG, Fünf Freunde, all of that. I was really into that. And I used it up until my teens, when I thought it was too uncool. Now I know better. But let's fast forward a few years now to 2019. I have 2 of these little ones myself, and I wanted them to have the same experience because I love that toy, and I want them to have the same toy. I want them to have the same experience. So who here is a parent? Give me a signal. That's like 50% of the audience. So there's no better way to disappoint a 4-year-old by giving them this. Even though brand new, they realize in an instant that it's old and crap, and they don't want it, and they will not understand it. So I was wondering, what's who war this tape deck recorder? How would this toy look like today, right? And at RubyConf 2 years ago, my friend Chris, who's in the audience too, shared the idea that you could replace cassettes with RFID. So huge shout out. So none of the ideas you see here are like mine, basically. I just saw that from him. Turns out this stuff exists. It's called the Looniebox. You can buy it in stores. It costs like $80. And then you need these little figures you put on top. It starts playing a song or an audiobook. And I think they're kind of expensive. It's like $8 to $12 a figure. And they're mostly bound to the story that's on them. And it's not homemade, so this is why this talk is... this talk could end here, right? But none of you would have any fun. And I don't have any fun to build it, so let's skip this. So I was wondering, how hard could it be? My kids ask this question all the time. So how hard could it be? Let's examine this together. What would I need? Well, I would need a Raspberry Pi and an RFID scanner. I will need an audio jack because I don't want to hear this all the time, but I also want to have the option to have a speaker attached. I don't want to have a cord to this thing, so I need a battery thing, like a power source, and I will need some sort of controls, right? And with that hardware, I think I could build a similar experience. So I started out buying different hardwares, and after 2 months of figuring it out and Googling a lot of shit, I ended up with this. And it may look so simple, but this was a huge accomplishment to me, which I recorded and shared with my wife, and I brought you the original video footage.
Oh mein Gott, Elena, siehst du das? Und das? Und das? Und die Kabel? Und das? Und das? Und wenn ich jetzt so mache, So. Tschupp. Und guck da. Guck. Nichts. Ich schwöre, eben ging's noch.
Yeah, classical programming experience, right? Once you demo to the customer, it doesn't work. I swear I brought like proof it worked a blink afterwards because I misconfigured something.
Also
So
jetzt,
here's a working version.
Da siehst du, und dann halte ich das hier, warte, so schräg. Ja, und dann halte ich das hier gegen und blub.
See in the background the new IDs appear. I was stoked. Like this was a huge success to me. Again, as said, like it took me 2 months just to get to this point. And this is basically what I had, right? I had this Pi. Out of this was attached to my computer. It was still on the breadboard, and it was obviously far away from done. So let's consider for now the Pi and the RFID scanner done. So what would be next? Well, next we bought a lot of stuff. I like buying stuff. I bought a lot of hardware. I bought a lot of electronics. And I also bought this. I also bought a speaker. But then when you look at the Raspberry Pi, the Pi has an audio jack out. So how would you, like, this doesn't work, right? So you need to connect it somehow. I had no idea how to do it. But how hard could it be? I mean, come on, it's just a speaker. Like this technique, like this stuff, this electronics exists for so long. So after a little bit of Googling and asking friends and not like too much effort, I found out I need an amplifier. And an amplifier is basically the thing that makes this work. So I ordered one online. It was pretty cheap. It was just like €8. And it shipped to my doorstep and showed up like this. Like, wait, it's not, like, this shouldn't be detached. So yeah, I figured that I probably need to solder this stuff together. I learned soldering in my first traineeship like many years ago. And you shouldn't do it like this. So yeah, I started learning soldering. So I soldered all the stuff together and I ended up with this. And I only burnt my stuff twice. So yeah, I figured it out. I made the next step. And again, I had this feeling of huge success. And I didn't want to stop there, right? I wanted to have, as I said, I wanted to have this audio bit in the middle. And obviously I only want the speaker to play if there's no headphone attached, right? So this bit of electronic exists. And I was wondering how hard could it be, right? Like this stuff exists in the world. It shouldn't be too hard. So I was Googling Wikipedia, and I found all this academia like electronic shit I didn't understand. Turns out the German version is for dummies. So the German version is way easier. And like this part I do understand. Like left, right, round, I know, like I can figure out what cables that are. You know, I have a tool to measure this. So let's look at the device in the middle and how it actually works, because for me, like finding this out was actually mind-blowing. So I brought this little video here. So it has 5 pins at the bottom, as you can see. And then ground is like always in. And you see when you insert a pin, it basically opens the circuit. And when you remove the pin, it basically closes the circuit. So it's passed through when there's nothing inserted in the audio jack. It looks so, like, it's so simple, but yet so smart. I found this pretty cool. And with all of this attached and assembled, I ended up with this. So I have the first basically version running. I have the speaker here. I have the first like device that should play something. And as you can hear, like there's a sound playing. So that was cool. I was pretty stoked. So let's consider audio done. The next question I was asking myself is, what's up with power? Like I don't want my kid to have a cord attached to the box. I mean, otherwise it could come in handy at some points, but this is not the user experience I want to create. So I was wondering how could I make power like transportable and mobile? And again, that's a problem that's already solved. So you do this every day. You probably did it like at the conference already. You can use a battery pack, right? A battery pack has enough power to power a Raspberry Pi for way too long. When it comes to miners. And we started out with one of the bigger batteries, which turns out was just too heavy, and I never had to charge it for a month. So we just bought a smaller version, which is lighter. So how hard could that be? Because I didn't want my kids to insert the USB plug all the time, so I need kind of a switch, right? And the switch, once you understood when it's connected and why 3 pins are necessary for a like two-way switch, because every direction closes one circuit, which makes sense. Once you like learn and understand this, actually this was not too hard. That was one of the easier things, especially given with all the experience I already earned in figuring out cables. So consider power down. And the next step on the way to make this experience happen was to make it look nice, right? So I bought this PCB. It's not custom designed. It's a ready-made thing from Conrad. And I wanted to have everything aligned pretty neatly. I spent a fortune on putting this fun, awesome icons on buttons. It's embossed, and it cost me 25 euro per button. So only the buttons are worth 100 euro. So there's no way I saved any money in building this myself, right? But let's consider buttons and controls done. So what would be next, right? We have checkboxes on all the items, and as I myself, I'm a software engineer. Like my hobby or like my profession is building software. Let's look at the software part and how the software part works. I'm in my day job a Ruby developer, and I have done some Elixir in the past. So I knew that Elixir exists, and that in Elixir, the so-called NERVs framework exists. We will talk about NERVs in a second. Basically, NERVs is a framework for embedded devices. So you can use Elixir to program embedded hardware using NERVs. So if you've never heard about Elixir, let me give you like a primer on Elixir. So I have this one-hand Elixir knowledge. It's functional and immutable. It has a Ruby-esque syntax. It's concurrent, so it just looks like Ruby, but it totally, absolutely does not work like Ruby because it's concurrent. It uses the actor model, so it passes around messages between different Elixir processes. It's loosely typed. This is, again, why Ruby is a good fit for the facade, basically. And it runs on the Erlang or Beam virtual machine, so it shares the same properties like Erlang. So that's pretty cool, but even though if Elixir wouldn't be that way, I probably would have used Elixir NERVs because it was, in the end, it turned out it was a great fit for my project. So looking at NERVs, as I mentioned, it's a device to build embedded devices, and it's also deployed in production use for some companies. But the most cases that are demoed in Elixir conferences are like projects like mine. So let's see what's out in the wild. So this guy, he's crazy. He built a gas power plant, like a biogas power plant, controlled by Elixir and NERVs. That was pretty cool. NERVs is also used to teach kids electronics. I did this with my son too, with NERVs and Elixir. You can power your bike jacket. You can even hack your car if you don't like your life that much. People use it to visualize like airplanes. There's obviously a lot of home automation because this is what Raspberry Pi is often used for, right? So there's various kinds of home automation and reading a sensor and like based on the value do something. It's like if this then that in a Raspberry Pi. And there's like gardening, and that guy, he's my favorite. This talk was titled Dadgeneering, and what he's basically doing, he's using image recognition techniques to detect what's a shelf and what's an object, and all objects need to be in shelves. So he can detect with his Pi if the room is clean up, if everything is in shelves and boxes. I think that's super awesome, and that's also built with NERVs and Elixir. So learn yourself some NERVs, especially as a parent, this comes as a general advice, but in this particular project, it was about the framework. Again, how hard could it be? I mean, it's a framework. We've all learned a framework in the past, right? Learning a new framework in software engineering is an accomplishable task, right? I was sure I would not fail. I don't want to comment on that. I mean, I got something done in the end. Let's put it that way. So let's have a little look at the architecture that actually runs this system. There's on the one hand there's the system, and then there's the player software. The system provides all functions to interact with the hardware. So there's the Raspberry Pi, there's interaction with the buttons, there's some callback that you can pass in to read out the RFID tags. All this kind of stuff runs in the system. These two things are two different repos, two different repositories. And it also runs the MPD, the so-called music player daemon. That's a piece of software, it's ready-made, it's a Linux package. That's often used in home theater and home audio, especially in the open source versions of that. And it basically it's like a Winamp, but with an API, and it always plays the audio locally. So that's basically the idea of that. So you have a server, and the server always plays its audio on its local audio out. So in this case, I can put it on the box, and I can use the controls wherever I want to have them. Like I could have them on my phone, or I could have them on my desktop PC to control this system. And it also runs NERVs, right? So all of this is in the system part. All of this is in the hardware. Whenever you start a project with nerfs, like this is one of your main takeaways if you want to do something with nerfs, use nerfs in gadget. That's one repo that's basically linked everywhere, and it gives you some really basic stuff that you will probably need. It gives you basic networking initialization, it gives you MDNS support, which once you understand how MDNS works, which is completely different than DNS, it kind of makes sense. It gives you over-the-air firmware updates, as long as you don't fuck up your network configuration, so this is why this stuff is fine together. And it gives you NTP support, because depending what you're building, especially if you deploy your devices like in the field and not at home, having them synced can come in kind of handy. First thing I learned is any non-default software requires a custom build of this NFS thing. There's one base build for every Raspberry Pi version. I'm using Raspberry Pi 3, so I had this Raspberry Pi 3 base thing, but I needed the music player daemon, which is not default software, so I had to learn it myself. I have to build it myself. And as this is a Linux kernel, I had to build this whole thing myself in a native Linux environment. As you can see, I'm running a MacBook, so Nerves kindly offers a Docker build environment. Turns out, Docker is not the fastest thing if you want to compile a Linux kernel. So my laptop was kind of frozen for just way too long, and it took me like 2 days, and it was waiting for this thing to catch up, and never happened. And I got pretty frustrated because it was inside Docker, it was for me kind of hard to debug and what's actually going on. Turns out it has to build a Linux kernel, but not only that, and this is what took so long, is that it used Git to check out the source, and as you can imagine, the kernel tree is pretty big and does a full checkout, so it doesn't even do a flat version. And this took forever. Like on my machine, on a single CPU core, this took forever and ever. So what I did is, because I'm a really clever guy, I spun up an instance in DigitalOcean, and I basically used the lower right version of that. So it's like infinite CPUs. And I used that digital instance to build this base image. That's cool. That's actually not the build, because I didn't took a screenshot, but it looked pretty similar. That was done in just 2 hours. That was great. So I had my base image. That was cool. Next thing I learned is there's no init. I mean, it makes sense once you think about it, but with my bare Linux skills, I was expecting init to be like existent always. Turns out that's not the case. You can't just start any random software in Nerves. You always need to write your own kind of init thing. Cool part, Elixir offers that. Elixir applications have like a tree, a so-called supervision tree, starting different applications. But I had to write a wrapper, and this is what you see on the screen, to wrap the music player daemon inside an Elixir process. So in Erlang, first thing you need to understand is that Elixir processes and OS processes share nothing but the name. Like they're completely different things. And with the ports, and this is what you see here at the lower bottom, you don't see anything. So this is what you see here at the lower end. It's basically a wrapper around OS processes. So that's pretty handy. Next thing when it comes to hardware is that Rfid is hard. Because I knew it because it took me 2 months, as I mentioned, to start it correctly. But naively as I were, like I was wondering how hard could it be? Turns out, yes, as mentioned, it is pretty hard. First thing I learned, and I want to share with you, because it was one of my big learnings, that Rfid is not NFC. It's 2 very different things. Often, scanners support both, so you can do both things. NFC is used for like Apple and Google Pay. It's a really complex protocol. It does usually like 2-way communication. It does encryption. You can do all of this. And in RFID, it's really just transmitting an ID over radio frequency, RFID, radio frequency identifier. That's all RFID is. And everything that's more is usually NFC. And often scanners work both ways. So usually, no, that's not true, but always, or most often, NFC scanners also scan RFID, not the other way around. There's active and passive is what you see most of the time. Passive is basically where you have an antenna in a chip. So this is also what's mounted below the figures here. You can see it here. So you see a chip and an antenna, and there's no power source in here. The power source is supplied by the reader. So the reader emits enough power for the chip to turn on and transmit its ID. So this is why this is, for me, pretty fascinating. It also supports different modes of operations. There's read-only, there's a key value tag database store, and there's blank text called write once. And I'm pretty sure all of you have already dealt, even though if you never actively done that, with RFID because it's deployed everywhere in shopping malls. And if you own a pet, like a dog or a cat, and they're chipped, this is also RFID based because basically everything RFID gives you is a primary key for a database. So that's this. You can also implement this in your hand, like they usually do it here, and it's kind of cheap. They do it here because it doesn't disturb, so your muscles and bones can still function normally. And it's just €80, and as I learned, almost every piercing studio does that nowadays. You can just go to your tattoo or your piercer, and they can do this. I started with this NFC reader. It's USB, and I learned that Nerf support for USB is pretty shitty. So I had to Google around and find this other scanner. And the best part of this other scanner, besides that it works, is that it comes pre-assembled. So I didn't have to solder on this chip myself. This one is called RC522, and it comes with an Elixir library. This is also why I picked that chip, because I found this library first and then I bought this chip. What was also pretty hard is debugging without a display. You see the box here, and there's a Raspberry Pi running inside that, but for me, there's no way to peek in it, right? I have no clue how to do it. Whenever the box is not starting correctly and the kids are complaining or I was developing it, I had to rip it apart, tear it out, and plug my monitor in. But then, even though if I would insert a keyboard, I can't interrupt the boot process. So the boot process would just scroll by. So I learned that Apple Live photos are pretty handy because in live photos or videos, I can just stop and skip and scroll around to see the error messages. Because as you can see, they just fly through. And when there's some weird red line there on top, it's gone now. So you would see me recording my own screen all the time and then going back and forth to find the error. I want to take this chance to also say huge props and thanks to the Nerfs community in the Elixir Slack. That's also pretty helpful. So whenever you have a question, the maintainers on the Slack channel, it helped a lot. That was really helpful to me. So the other part is the player software. The idea of the player software is that it's completely independent from the system. And as said, it's also running on Elixir and on the Phoenix framework. Because I'm a web developer myself, for me, this part was kind of the most obvious one. I knew how to assemble a web app that just scans a tag and then plays a tag again, plays whatever's assigned to this tag. I thought this easy. And what's cool is also that the player software has just one dependency, which is a running music player daemon. So I could just start a music player daemon on my machine and develop the software for the box, the actual software, just on my MacBook. I didn't need even the box. So I could develop the software when the box was not near. I could be here in a conference or whatever. So what this software basically does is once the reader detects an RFID, it uses this RFID to create a playlist or this ID from the RFID. And then there's the web form where you can upload any MP3s. And then once you uploaded this MP3 files in this playlist, you basically have one ID assigned to a set of MP3s. And then the software goes ahead and stores all of that in the correct folder. And that's it. Right? So this is basically everything it does. And whenever it sees the same tag, it starts the playlist. So this is what the software does. And what's cool, there's no database. As I learned, IoT devices can crash and shut off at any time. Nerfs runs on a read-only file system with a dedicated user data portion. So running a database is particularly unsafe as running a file system or write file system. And it's also uncool. So this is why I think this solution worked out really well. And NPD also offers a key value store, which is, again, kind of database, but I used that for play counts. That was easy. That was boring. This whole project was the most boring thing to me because this is my day job. Writing web software was easy. All of that is open source. It's poorly documented, but if you're interested in building this, you can find it online. And the next step would be to putting all of this together, right? So while developing this project, it lived in this Tupperware box, which is not something you would want to give to kids, right? So we found this box. We wanted to put this in this luggage here, and luckily my wife can draw pretty neatly, so she drew this space thing on top of that. We found the UFO, and we wanted to have a status LED. So the thought was, let's just pimp this a little bit and don't use just one status LED, but use a couple of them. So we could have a boot sequence. So this is a video, and as you can see, there's a little boot sequence, and the UFO goes up and down. That's cool. And then we assembled it one night. I remember my wife was highly pregnant at this point, but we had a lot of fun assembling it. One thing is that when you're not good at soldering, there's a lot of really loose solder pieces, and we ripped apart one of the flips while inserting it in the box. But we had it inserted already, so I started soldering in this paper box. That was like shitty. That was not a good experience. So make sure to check your soldering things. The next is the demo part. Like I wanna show you what we built. So let's see. You can see me here, and I hope I get the software running here too, so that you get a video. Let's see if that works. Okay, give it a second. No, it's not connected to the Wi-Fi. Let's give that one more try. Because I had to bring my own Wi-Fi, so this runs on a Wi-Fi, but I had to bring my own one. Yay! So it functions. Okay, so you can see the details here. So this is the box. It's also painted on the back. Oh yeah, you can see it. Thanks for the heads up. You should see it now. Yes, but it still has this. Okay. Cool. There's this. Okay, now we can see it. All right, cool. So this is the box. This is the front side of the box. I already started it because start time usually takes a while. We can also have a little peek inside it if you like. So this is the box running. I haven't demoed it yet. We started mounting this scanner at the back, but you will see in a second why this was a stupid idea, because it just gives a bad user experience. So the box booted now, or is booted, and then I have this tag here. So there's this little Olaf figure, son loves it, and it has this RFID tag below it, and I could use that and go close and scan it. Oh, and as you can hear, or maybe not, I can get a little closer. It starts playing, but as said, it also has an audio jack. Maybe I just turn the volume a little bit down before. So you can listen to Frozen in the cinema. Yeah, so it works. You can skip a song if there would be more. So if the playlist ends, it just stops playing. And there's volume controls. And this is basically it. And there's a lot of various versions of that. Like we have tons of Disney songs. We have Pepper Woods. We have all this like well-known child books. So here's the Pinocchio version we could play. And now let's have a look at the web part. Let's see. Work email. Yes, it works great. Okay, you can see that. That's cool. So now let's imagine you want to upload a new song, right? You want to create something new for kids. And all of this is like, I've built this myself, and as you can tell by the UI, I'm a backend engineer. So I want to upload something new, and this is something I really like. So you can take, for example, the RFID thing they gave you here for the conference. You can see me anymore, so I don't have to do this, but like these RFID things that they gave you for the conference, I can hold it close to the scanner, and as you can see, the ID pops up. So you can use anything that's RFID. So that's pretty neat. And then I would go here, and this is the neatly designed thing, and I can use some BB&Tina that we have uploaded and save it again. And that's it. It's uploaded, and I can go ahead and scan the same tag. And it's a demo, it doesn't work, probably. Yeah. Okay, usually it works. But yeah, demo, you know this, the demo guy's on it with me. So that's for the box. So let's continue a little bit, because this is not where everything ended. As you've seen, there are various different kinds of RFID chips. I thought that my past experience in tabletop gaming would help here, but turns out that cool. So it turns out that these bases are not even. So we went to the Home Depot, and I had to build this myself. This is a very cumbersome work. But yeah, we end up with the bases for the figures. So also the bases are like custom made where we mount the figures on. Turns out that it's really hard to store many of this. So it also gets really expensive if you buy all the figures, and then it also gets expensive labor-wise. So we ended up mostly using this credit card size cards because they're easy to store. So I got my first happy customer, and in this video, you see that the scanner was at the back. So it was not a good user experience, right? So this thing at the bottom, yeah, that was not easy for him. But he liked it a lot. But as you may remember, we got 2 kids, but only 1 Looniebox. So that's a problem right there. So we needed 2, and I thought, like, okay, challenge accepted, but this time I want to bring it to next level. So we found this thing online, we ordered it at eBay, used, and I teared it apart, and I tried to fit the same components again in this real cassette tape deck recorder. Turns out, if you order just like 10 different battery packs on Amazon, won't fit, and even the lid closes. And the Pi also fits in there. It also comes with a speaker. That's pretty neat. And I was afraid because we ordered it used that the speaker may not function. I had to, fumble around with all the plastics and get a correct speaker. And I did a test. This is a video, but you can't hear it anyway because it's not loud enough. But it was playing. That's pretty cool. So I used this as a test. So the next problem I face is that this thing has a lot of plastic components, right? And in this paperback box, I could just rip parts in. But for plastic, I would need to go into CAD software and design my own thing. So I learned that Tinkercad exists and that websites exist where you can upload a 3D model and they send it to you via snail. That's pretty neat. So I also learned how to design my own custom components and 3D print with not my own printer. So yeah, we printed our own components to do this box. This whole thing is still work in progress. Like, none of this is done or finished. This still basically lives in that state at home. I started with the software first because, as you can imagine, the kids, they want to share this. No, they don't want to share this. I want them to share this. And so all of these devices and keys, so the playlist and the data, need to be existent on both devices. And as we're using Erlang and Elixir already, let's form a cluster, because what's better than a single computer is connected computers. So if you have a node, and then a second node joins in the same network, they would detect via a gossip protocol and form an Erlang cluster using libcluster. So now our child toys are running inside a cluster, because they detect themselves, then they find themselves, and then what every box would do, every box in this cluster would ask all the different boxes it knows inside the cluster, what are the playlists you have, and what are the playlists you know. And once it's seen that, it compares it to the ones that the box itself has, and then you can compare basically, or what songs are missing. And then the box would go out and start fetching playlists and songs over Wi-Fi from other boxes. I don't want to deal with the cap theorem and eventual consistency and everything, because this is shit and it's my free time. So this is just additive syncing. There's no way to delete things ever. It's a 128 gigabit SD card. Once that is full in all boxes, we're just through. But till now, it has worked out really well. And it's also a great backup mechanism, because once you have to flash an SD card, the whole user storage is gone too. And once you have this solution in place, you only have to destroy one box at a time, and then they would start syncing again. I think that's also pretty neat. So you may think now, that's cool, but why? I mean, come on, that's stupid. It was a huge time sink for me, but I don't regret it. It was really cool because, one, I had a lot of fun. It was a lot of fun doing it, and it was also a lot of fun to rediscover my inner child. I also talked a lot with my mom about my childhood, apparently, just reading this. I got all the pictures, we flipped through old photos, and all of this was super fun. And I could build something, right? As software engineers, we are so used to the fact that we should take off-the-shelf software because you don't have to bear the maintenance costs. And I'm sure this conference, all the other talks mentioned that you should take either their off-the-shelf software or someone else's. And for this project, I could just screw all of these ideas and build something myself. And this is something that I want you to take away from this talk too, that building something is actually something that we all enjoy, and especially as growing older in software and growing old in software engineering, just the fact that building something is fun is something that we should bring up every once in a while. That's everything I got. Thanks for listening. We do have some time for questions. I intentionally left 10 minutes because in my experience, I learned that there may be some questions. I'll also stick around. I have the box with me, so if you have any questions, just let me hear. I think you have to wait for the mic.
I had a similar problem, and I'm trying to build something similar
Awesome.
with an old Android phone. Have you thought about the microphone part? Because we had a similar device with cassette, with tape and so on,
Yeah.
with the microphone. Are you developing something with the to use
Oh,
the
that's-
microphone and,
yeah, that's
and
cool.
sing along?
Yeah, we totally need to talk because I have no idea yet. So to answer your question, I have no clue. As you saw in the second box, like there's a microphone attached. We didn't throw it away, but yet I have no idea how to do this. I hope that some ready-made components exist, but yeah, as I mentioned, I have no idea. I hope it's possible. How hard could it be, right? I don't know. I've never looked into this yet. Sorry. Do we have more questions? Do you want to hear more songs? I have the whole Disney collection with me. Cool. So there's no more questions. I think I'm not missing anyone. You can have this last 7 minutes yourself, and if you want to just play around with the box or want to have a closer look, I invite you all to come up after the talk, and then we can have a look together. Thanks for coming, and have a good day.